Welcome to Scalable CTO. I'm Bob Dickinson. Today we're going to talk about CI/CD. Let's jump into it. So this will be a fairly technical discussion. I'll talk about some CI/CD principles in general, kind of an overview, and then about GitHub Actions, which is what we use to do our CI/CD. And then we'll go into how we actually did it with our Flutter mobile apps, packaging up for the app stores, and for Next.js app, packaging and deploying to Google Cloud Run. There'll be a little bit of hands-on keyboard maybe toward the end of this, and we'll go through some of the actual implementation of this. So first of all, what is CI/CD? It's continuous integration, continuous deployment or delivery. And the idea is we're trying to get consistent, fast, reliable, high-quality releases with no external dependencies by anyone on the team at any time. So no dependencies on any developer workstations, any software versions, dependency versions, accounts, tools, credentials, secrets, environment variables, nothing. Just everything is completely fully specified. So we fully automate the build process, including testing and other kinds of validation. And we fully automate the deploy and the release. So everything is push button and nothing is dependent on a developer machine. And what that looks like day to day for continuous integration, this is sort of the model that anytime anybody's worked in a engineering organization of any scale where you're using version control, this is the notion that everybody's going to contribute code to a single shared repository. You'll have workflows for that. So typically you'll branch and submit a pull request that'll be reviewed. And when you do those reviews, you'll have gone through a build and test cycle typically before you can push to main. So we'll build the code, we'll test it, we'll run unit tests, we'll do other kinds of validations, maybe a linter, maybe dependency validation, maybe static code analysis, any sort of code quality checks that need to be done before code's checked in, and also manual PR review. So this is sort of the normal GitHub flow that people are used to. And in our case on mobile, we have an additional step there, which is to actually build the packages. There can be cases, at least especially in the Flutter environments, where the mobile builds can succeed, or the Flutter builds can succeed and tests can pass, but the mobile builds might still not succeed because of the way the packaging works and the dependencies and native libraries. So you have to actually validate that you can build the mobile packages as part of the continuous integration. And similarly on the web server, we run the unit test code and the integration test code, but we also have to do a build because the test code will run even if there are problems with the build. So we want to run the linter, and we want to run the actual build process that'll tell us if there's any compilation errors anywhere in the code. And then on the continuous deployment delivery for mobile, we want to be able to create and sign packages for the app stores. And that can be kind of a bear to do automatically. There's a lot of moving parts. And we also want to be able to submit the package to the app store automatically. And then on the web server, we want to be able to deploy to staging or production, and we want to be able to do traffic management to be able to test those releases in production and then push traffic to those releases. So we'll talk about GitHub Actions, which is what we use. It's a CI/CD platform that's built directly into GitHub. It allows you to automate your workflows, build, test, deploy. You can actually do a lot of stuff with it. Anything that you want to do that's triggered from anything that happens in GitHub, you can drive with the system. So it's essentially workflow code that you write in your projects and YAML files in your projects. I'll show you what they look like. And there are various activities or actions that happen in GitHub which cause these jobs to kick off, and the jobs run and do your CI/CD. So they'll do builds. They can do all kinds. I'll just show you an example when you get the idea. You can also manage your environments with environment variables and secrets within GitHub. And there's a ton of GitHub Actions in the marketplace that are third-party libraries that do like everything. They integrate with anything you'd possibly want to do. So let's go look just real quickly what one of these looks like, just to give you an overview of GitHub Actions. So you have a .github workflows directory, you create a YAML file in there, and then you define a GitHub action, a workflow, I guess, technically. So these are, they'll have triggers. This is a manual trigger. They're typically automatic, so on a push to main or a PR, these jobs will run. You can set up some global environment for this whole job, and then within the job, you can have individual jobs within the workflow. So there's a build Android job in here and a build iOS job, and then within the jobs you have steps. So within one of these jobs, build Android, we tell it what operating system we want to run on, Ubuntu latest, and then we're going to go through a whole series of steps. So this is a lot like building a Docker container. pretty similar, like conceptually, except I think a lot more powerful in terms of the kind of integrations you can do. So you have these jobs you can define. There are environment variables and secrets that you can feed into those jobs if you need to manage those. So we can go to GitHub Actions and see that I have a secret Google credentials, which is how I authenticate to the service account for my Google services. And then I have some variables, only a couple on the mobile build. So I can actually maintain these in GitHub and inject those into my GitHub Actions. And then I have a record of all the times these actions have run with a log that shows me the individual jobs. And if I drill into those, I can see all the steps in those jobs, and I can see the inputs and outputs of all the steps in the jobs. So that's just a really high level overview. It's super convenient. If you don't already have another CI/CD system, I don't know why you would use anything other than this. It's basically free. It's built into GitHub. It's triggered off of the natural actions that you do already. And I'll show you how we've used it to sort of do some external triggers. But yeah, it's very cool. It's easy to learn and use. If you haven't used it before, go spend an hour watching YouTube videos, and you'll be able to do amazing things really quickly. So let's talk about secrets management. If you're going to do CI/CD, it's probably a good time to establish a secrets manager. I would really advocate you start a secret manager as soon as you start your project, because especially with mobile app development, you're immediately going to start generating secrets, and you're going to have to manage them somewhere. So it's either going to be a bunch of files on your local machine, or a bunch of state in your local machine and your tools, or you're going to put them in a secret manager. I had to go round all those things up, and it was a little bit of a pain. It would have been nice to have them all in one place. So we use Google Cloud Secret Manager. All the cloud environments have a version of this tool that works almost exactly the same. Azure and AWS have very, very comparable offerings. So it's essentially a user interface that allows you to, and a set of APIs that allow you to define secrets. You can read and write those secrets if you have appropriate levels of access. It has very granular permissions in terms of who can access the secrets. It has versioning. It has access logs, so you can see how they're being used. And it integrates really tightly with Google services that need access to secrets, so they can access them directly as secrets. And I'll show you an example of that when we get to the API server. And how we do our GitHub Actions with that and pull secrets in. On the GitHub Actions side, we actually pull secrets from the Google Cloud Secret Manager from GitHub Actions, and we use these GitHub Actions, the Google GitHub Actions auth and Get Secret Manager secrets actions to do that. We could just run gcloud secrets and use the command line and pull the secrets in that way once we're authenticated to Google Cloud, but by using the Secret Manager secrets action, it actually pulls those values in as secrets within GitHub Actions. So GitHub Actions knows that they're secrets. There's some masking rules that happen within GitHub Actions to prevent secrets from accidentally being logged to the console. And by using the Secret Manager secrets action, you prevent that from happening, which would be trickier to do if you didn't do that. In terms of security, so the right way to authenticate between GitHub and Google Cloud Services is through Workflow Identity Federation, which is an OIDC mechanism for Google workflows to be able to get short-lived tokens to run their workflows against Google Cloud. The way I'm doing it right now is just through a JSON credentials access to a service account, which is not great. Those don't expire, can't be revoked, so it's not a good model. But Workflow Identity Federation is the way to go, which we'll transition to that at some point. And then for principal of the least privilege, we probably should go to dedicated service accounts per repo so that each repo can have access to only the secrets it needs. Right now, we just have one service account for GitHub that access all the secrets that it needs. So we should probably split that up. So let me just give you a quick overview of what that looks like, what the secret manager looks like, just so you can see. So you go to security, secrets manager. You got to get good at navigating the million menu items. So this is it. It's pretty simple. You get a button. You can create a secret. Secret has a name. You can put labels on them. They have values. I'm not going to open and show you the value, but you can look at the permissions. And again, these can be pretty granular. You can do it by role, by account, and also logs. So pretty straightforward. They're also versioned, so you can refer to a specific version of a secret. You can use :latest just to get the latest version of the secret, which is what I typically do. But you can pin to previous versions of the secret if you want. So pretty straightforward. Just a big pile of secrets that has good access control around it. And this is where we keep everything. All right, so I'm going to show some examples of what we've done for our CI/CD, and I've done it in a way that is probably not the way you would do it at a little bit higher scale. I'm a solo developer, so I push to main many times a day, dozens of times a day sometimes, and I don't want to run these full CI/CD jobs every time I push to main. If I was in a more scaled environment, that would look more like a branch, and I would push a whole bunch of things to a branch and go through a PR process, and maybe every day or every couple days I would merge that branch, and then you would run the CI/CD. But I'm not really there yet. So they're structured in a way that the CI part of it is kind of separate from the CD part, and it'll be pretty easy to build a trigger for PR or push to main on the CI part when I'm ready to do that. When I add a second developer. But right now, these are going to be just manual jobs that run all the CI/CD in one job. Just so we have that context out there. It's not exactly the way I would do it at a little bit more scale, but it's also going to be it'll be super easy to change when the time comes. So we'll talk about the mobile apps first, and before we do that, let's talk about the publishing model. So in the Play Store, you have what are called tracks. There's internal testing. There's an internal testing track that's named internal in code. There's closed testing, which is invite only. So you can have external users, but only people you invite either by email or giving them a link. There's open testing, which is like a discoverable beta that people can download and test. And then there's production. And iOS has a similar model. They have TestFlight, which has internal testing, which is exactly the same as the internal testing on the Play Store, internal users only, then external testing, where you can invite users to test, and then full release. The interesting part of this, so for internal testing, this is literally internal. Like these are not just people that are part of your company. These are people that have accounts on the Play Store or on the App Store Connect account. So these are like other developers and maybe testers and people who actually have accounts on the App Store. So this is going to be a small set of people. And typically this closed testing or external testing is really where you're going to actually test, even for a lot of what are essentially internal users. In order to do that on Android, you have to go through a full review. So to release on any track other than internal testing, so even closed testing, you have to go through a full review, which means you have to agree to every agreement, you have to fill out every questionnaire, every form, every disclosure, upload a bunch of screenshots. It's like a whole process that'll take hours to do. You have to refer to parts of your website that describe processes for how people can get their accounts removed and get support, and you have to have a public phone number. There's just a whole bunch of things you have to do. So you have to go through a full review just to go to closed testing. Exactly the same review you'd have to go to full production, all of that stuff. And then they say 4 to 10 days. It took me about 3.5 days once I submitted everything for this to get approved. But you're going to have to submit all that stuff and then go through this approval process just to do closed testing. So just so you know that. On the iOS side, it's actually a lot more lenient. To do an external test, you have to I call review light. You fill out one page that has, 8 questions in it. So it's like your name, your phone number, your personal phone number and email address, a couple of check boxes, and you have to give an account that you can use to access the application. So, and I actually saw, this took about an hour from the time I submitted it till I got approved, and I saw them download the app and access the app in that period of time. So a person presumably actually just downloaded and validated that was an app. And then I got approved quickly. And then when you full release for distribution on the iOS App Store, then it's just like that. It's just the full, exactly the same as the Android Play Store. But you don't have to do that until the very, very end. Whereas with the Play Store, you got to do it pretty early in the process. And the reason that kind of matters is because when you're doing the CI/CD with the tooling that is provided on Android, you can only automatically publish to any track if your application is in completed status, which is when you first start an internal testing track, you're in draft status. And until you've submitted for review and been approved for any other track, your app stays in draft status. And as long as it's in draft status, you can't publish anything automatically. So you have to go through here and do this closed testing review and get this approved just so that the CI/CD can push to the internal testing track. That's not documented anywhere in the Google documentation that I could find, but I found enough anecdotal evidence, and then I verified it myself that that's actually how it works. You have to get through this full review before the CI/CD can push to internal testing. And then once you do that, you can push to any of these. So right out of the gate, you can do this internal testing, publish anything you want, distribute as soon as you push the button, it gets distributed, but you have to go manually to the store to do it until you've gone through this phase and enabled your application to get out of draft status so you can do it automatically. Okay. So the goal for both of these is we want our CI/CD to build, validate, sign, and publish to the internal testing track, to either internal track on Android or the test flight internal testing. So we want to be able to push a button. 10 minutes later, we want to hear a ding on your phone and be able to download it from the App Store and test it. But after that, anything further than that's going to require manual promotion. So you're going to have to go to the Play Store or App Store Connect. And if you want to go to an external testing or any other phase of release, then a person who has access to App Store Connect is going to have to go do that. I think that's fine to have that be manual. That's something you want to have a little bit of control and process around. You might still have a CI/CD job to actually do the thing to push the button, but I think you want to have that separate from, this is sort of any developer who pushes any code and wants to test it can do that automatically. And the promotion to any other track, I think, is something that needs a little more process. So that's how it works now. That's how we have it set up. So our goal, we want to build, sign, and publish mobile apps in 10 minutes, which we can do, and I'll show you how that works. I'll show you how that works right now. So this is the job that we already looked at. Let's go to the code and actually look at the code for this. So we'll go and look at what the code actually does here. So it's a manual trigger, first of all. And I define an input here. So I actually ask you which platform you want to build. By default, it does both, but it'll build either or both. And the reason I do that is because I do this manually a fair amount. And the iOS build takes about 8 minutes, which is fine. One of the things I didn't really talk about is with GitHub Actions, you get 3,000 minutes on any paid plan a month, which is plenty. Like if you're doing like daily or even multiple times a day builds, it's hard to imagine you're going to really exceed that, maybe. But iOS builds require Mac images to run, and Mac images are built at 10 minutes per minute. So an 8-minute Mac build is 80 minutes of charge time. So it'd be fine to do that once a day. It'd be fine to do it on a branch merge, but as often as I push to main, I wouldn't want to do it every time. So I don't always build iOS or Android. I sort of build whichever one I want to test if I'm doing something that's platform specific. So anyway, you have your choice. You can build either or both. If you automate this, obviously, when you automate the CI side, you're going to build both. So we define our Google Cloud environment, which we're going to need in a minute. And then let's go look at the build Android. So it says if we're building Android or both, it's going to run on Ubuntu latest. So this is where it's going to kind of smell a little bit like building a Docker container. And then you have a whole series of steps. So some of these steps, the ones that have uses, this is using another action. So the first thing you're going to do is check out the code, which is the first step of every action pretty much. And then I'm going to set up Flutter. I could do this with commands. Like you can see down here with the run command, you're just running a shell command. So I could do that with shell commands, but there's a nice action that does that for you, that does a little bit of the setup for you. So I'm going to set up Flutter. I'm going to go get its dependencies, and I'm going to run the tests. So one of the things about these steps is that if any test fails, it'll stop execution of the whole job. So you don't have to sort of check to see if the test pass. If they fail and return non-zero, then the job ends. So assuming we get through the test, we're going to authenticate to Google Cloud. So I'm going to pull this secret that's managed in GitHub that I showed earlier. I'm going to use those credentials to authenticate using this Google GitHub Actions auth action. This is actually going to write a file in the local state that's going to allow me to run other Google commands later. So then the very next thing we're going to do is we're going to go to Google Secrets Manager with the same Google GitHub Actions, get Secret Manager secrets, and we're going to get some secrets. And as I said, these are going to be gotten in such a way that they're going to be treated as secrets by GitHub Actions. So none of these will be leakable out into the console or into the output of the action. So we're going to go grab these from Google, from the Google Secrets. And then we're going to go set up our JDK to do the build. So we want a specific version of Java for that. And then we're going to build and sign the Android app bundle. So there's an action Flutter build. So this is sort of a Flutter specific builder that does the right kind of setup for that. We don't use the default build command. So we are building an app bundle, which is not the default. We're doing it in release mode. And then we're going to pass some defines. They call these environments in the build, but they're really sort of like they're basically just build time defines, or compile time defines. So we've got the git commit hash. So we're pulling this GitHub SHA out of the job state, and then we're going to do the GitHub run. So that's going to be the run ID and the run number. So the run ID identifies the job that's building it, and the run number is the number of the execution of the job, which I'll show you how that works in a minute. So the code's in the current directory. We're going to pass in our secrets, and it's going to go build and sign the Android app bundle. We're going to rename the bundle because we're using these files in a few other places, and I want them to be named consistently between iOS and Android. So we're going to rename it TeamSpark AAB. Now we're going to upload the artifact. So that will basically save this file as part of the job state, which allows us to go back later. So I can go back and see, I can get any run number that was deployed. And if I want to go get the app bundle or the APK file, I can go back to the job that produced it, and it's still going to be attached to that job. So I can actually get the file. The Flutter builder doesn't package symbols properly, and the App Store or the Android Play Store complains about that. It's sort of annoying because Google owns both of those things and they don't really work together. So you have to go build your debug symbols kind of on your own. And this was a little bit of trial and error because there aren't really any instructions about how to do that, about where to find them or how to package them. But this is where you find them, and the way you have to package them is you have to cd into the directory they're in, because there can't be any path information above the lib directory in the zip file. So it needs a zip file that's like formed very specifically with that set of files for your native libraries. And then we're going to go upload that whole thing to the Play Store. So we're going to use, again, our secret. We're going to give it the package name, the internal track, the completed status, so it'll publish it automatically. This is our release files, our app bundle, the debug symbols that we made right up here in the zip file. And then this mapping file, if you don't include the debug symbols, it's able to find the mapping file by itself. But for some reason, when you include debug symbols, it can't. So you have to specify that also, which is not a big deal. So have to make sure to include that. And this is all required if you want to be able to get this through clean with no warnings, which is pretty important. If you don't actually have to have these debug symbols or the mapping file, but you are going to get warnings, and it may prevent you from being able to automatically push if you have any warnings. So this will produce a clean build. And then let's go look at what iOS looks like. It's very similar. We're going to check out the code. We're going to get Flutter set up. We're going to get our dependencies. We're going to run the tests. We're going to opt to Google. We're going to get the different set of secrets this time for this job. I started having a dependent job that got all the secrets, but GitHub Actions is really picky about letting you pass secrets between jobs because it knows they're secrets. So it's actually easier just to get the secrets you need in each job, which is what we do here. Now we're going to go build and sign the iOS app. And again, you're going to see we're going to run a specific Flutter build command, passing the same pound defines and the secrets that we need for that. And we're going to take the iOS artifact and we're going to take the iOS artifact and upload it just like we do with the Android one. So now we have the AAB and the IPA are going to both be attached to this job state. So to run App Store Connect, to upload the file, the only way you can authenticate is with a physical file in the file system. So it needs a physical key file, this P8 file. So we have the contents of that file stored as a secret, and the file has to be in a specific location with a specific name. So it has to be in private keys named authkey _ the key ID .p8, and the contents have to be the key file. So we're going to go create this key file, and then we're going to run an ls to just show us that the key file got created in the output so we can validate it. And then we're going to upload to test flight. So we're going to run xcrun al tool. So xcrun is xcloud run and al tool is application loader tool. So that's the abbreviations for those things, just if you're curious what they are. So we're going to upload the app, iOS. We're going to pass it the key and the issuer, and it's going to use this P8 file for authentication. So this is actually not quite as much of a hack for access because these credentials are created specifically for different uses and they can be revoked later. So this is a pretty reasonable way to access the App Store, more so than the way I'm probably accessing the Google accounts, service accounts. And then when we're done, we're going to clean up the auth key file. So as I said before, if any stage fails, none of the jobs run after that. That's not exactly true. If you have an if always, the job will run whether the steps prior had failed or not. So we have this if always here just to make sure we don't want to leave this key state around. It doesn't really matter because this is the end of the job, but we don't want to leave, if somebody was to add some stages after this, we don't want to leave that private key sitting around any longer than we have to. So we'll clean it up. And then again, we'll list the directory so you can see that it's empty when we're done. So that's the gist of how we build those two things. This 169 lines of code took a lot longer to write than you would imagine, a lot of trial and error and a lot of sort of figuring it out. There's some examples of people using these, these shared actions of how to use them, but I didn't really see anything that was complete and that solved all the problems that we had to solve. So let's go back and we'll look at what it looks like when you run these jobs. So when you run the job, if I go click publish sign or build sign and publish mobile apps, I can go run workflow. And I can click if I want to run iOS, Android, or both, and it'll kick off a job that will do all the stuff we just showed, build and sign and upload. And if I want to go look at how one of these jobs worked, I can go in here. Here I have a build Android and build iOS. I can see the times they ran. The billable time is not exactly right. It's the total amount of time between these jobs, but it doesn't encompass the fact that the iOS build actually costs 10 times as much as it says here. So that's not really 18 minutes. That's more like 90 minutes is what's going to cost you for this job. Again, not a huge deal because the time's pretty cheap, but just so you know. And then if you go down to artifacts, I've got the app bundle and the IPA attached to this job state. So this is the exact things that were built when I ran this instance of this job. And if I go into either one of these jobs, I can see all the steps of the job, how long each step took. And if I want to go like look at one of these steps, I can see the exact input and output of what happened. So I can see, okay, it ran XC tool. This is exactly what it passed in on the command line. That's the environment it had, and there's the output. So I can sort of do that for any of these steps. This is mostly useful when this is not a check mark, when that's an X and you need to figure out why the step failed. But it is nice that you have the full log output and it's searchable. It's a pretty nice interface for that to sort of keep track of just how things work. So yeah, that's the gist of how we build that. And it works. You can push the button and within 10 minutes you get a ding on your phone, Android or iOS. You can go click a button to download it and you're running that code on your phone, which is pretty awesome. So an important safety tip with Flutter projects by default, pubspec.lock is going to be in your git ignore, which means it's not going to be under version control. But iOS podfile.lock will not be, which means that it will be under version control. And that is potentially pretty problematic. I actually had this fail before I fixed this because a version that was in my pubspec YAML floated by just the patch version went up one tick, but that changed its dependency on the native file that it depended on. And that caused the build to fail because the podfile.lock had a different dependency in it. So when you start doing automated builds with CI/CD, now is the time to make a choice. You can either lock both of these files or you can not lock both of these files, but you can't lock one and not the other. And I think the best practice is just to lock them both, which means that the developer making a dependency change is responsible to sort of validate that the dependencies go together, that the build works. And that the next developer who checks that code out is going to have exactly the same set of dependencies, as opposed to letting everybody sort of float, which could cause some less predictable behavior. Because I want to make sure that these builds always work, then we're going to lock the pubspec and the pod file, meaning that those locked files will always be consistent and they'll always work. So anyway, not a big deal, but you're going to need to change your git ignore to check in the pubspec.lock. And then the other thing is when you're passing in those defines into the Flutter build environment, the way that you get access to those inside of the Flutter app is through the string.from environment with the name of the variable. I didn't read the documentation carefully enough. I went back and read it after I spent 2 hours debugging why this didn't work, and I figured out that the documentation actually is correct if you read it very carefully. So these what they call environment variables are available at build time, but they're available only at build time. They're not available at runtime. So if you call string.from environment without the const, this will never result in giving you the actual value. You have to have the const in front of it, which means at compile time, it will go compute this and get the variable out of it. So it's a little bit of a weird thing that I didn't expect, and based on Stack Overflow, I don't think a lot of people expected. But that const is, in this only case I can think of where that actually makes a difference in all of this development in Flutter, but it makes a difference here. So you have to have const in front of it if you want to be able to extract those variables. And I'll show you kind of how one thing we did with that. This is a little bit inspired by how the Vercel integration worked and how nice it is to be able to kind of connect your code to what you're running. So in the TeamSpark app, if you go to settings, you can see this TeamSpark version. If you click on that, it doesn't do anything, but if you long press it, it will bring up this detailed about box. It'll give you a bunch of diagnostic info. So what this does is it'll pull package name, build number, the package name, the build number, and the name of the app and the version will all be from introspection of the package itself. So those will all be exactly what the App Store thinks they are. And then we have the build run. So this is the job that built it, it was run number 55, which is the one that produced this particular app. And then we have the git hash, so we can go find the exact source code that produced this. So that's kind of nice to be able to connect that end to end. And if we go back here and look at the jobs, you can see there's 55. So that's the one that produced that build that's running on my phone right now. So that's the gist of how the mobile apps work. And then let's talk about the website. So initially we started out with the Next.js project in GitHub on Vercel that Vercel actually set up. I use the wizard for that. It's like a 3 to 5 minute. You answer a few questions and you have like a Git project that's integrated with Vercel that has CI/CD integrated and an SSL cert and everything. It's super cool, very slick. We later separated that out so that the website and the web app are still on Vercel running that same way, but the API server is running on Google Cloud, on Cloud Run. Talked a little bit about it in a previous podcast episode. But I'll show you like how Vercel works, right? It's pretty clean. When you push, so it's set up as an app integration. So if I go to GitHub and I go to my GitHub apps on the repo, that's the website, you can see that it has this Vercel integration, and I can go in there and it'll make me MFA, but I can go configure that. But it basically just turns it on and off. It essentially says, hey, when you push to main, we're going to tell Vercel about it and let them grab your code. And what Vercel does is, this is the Vercel side of that. So you can tweak a few things. You can implement some deploy hooks and some build steps, but basically they're just going to kind of do the magic thing, which is what you want most of the time. And if you're just building a straight website or a simple web app and you just want to get it up quickly, this is totally fine. If you want to do something more complicated, it's pretty easy to detach this and just set it up as a GitHub action, do the same thing to push to Vercel. But and then the nice thing about that is you can just go here and say like, oh, this is what the page I pushed was. It was 3 days ago. This is the Git hash and the comment that went along with that of the last thing that I pushed here. So it kind of connects it end to end. So that's nice and easy out of the box, but we needed a little bit more flexibility for what we're doing for our deployment. So we made a deploy to Cloud Run from source action, GitHub action, and I'll show you how that works. It's manually triggered. It'll give you the option to route traffic to the new release or not, and there's some sort of esoteric issues with how that works. And then we'll also inject the Git hash into the revision config. So let's go look at what this looks like. This is our API repo. Again, .github workflows. Here's our YAML file. You can name those files anything you want. It'll pick them all up. So deploy to Cloud Run from source. Again, it's a manual trigger. We take an input. The input is, do you want to route traffic to the new deployment or not? If you do, it puts the new deployment as latest. If you don't, it marks the new deployment with a tag called staging, doesn't route any traffic to it, and gives you a URL to that so that you can go test the staging revision, and then when you're ready, you can move the traffic to it. So pretty similar. We're going to set up our GCS environment, specify the permissions. These are just the default permissions, but it doesn't hurt to be explicit about it. Again, we're going to run a Ubuntu latest. We're going to do a checkout, same as almost every one of these. We're going to set up Node.js, so I need a specific version of Node. We're going to install the Node dependencies. We're going to build our Next.js app. So this is going to compile everything and lint it and do a few other checks. So we haven't run the test yet. We just built it. Then we're going to auth to Google Cloud, same as we did in the other job. And then we're going to get to the secrets that we need. We're only going to use these secrets to run the test. We're not actually going to use these secrets when we deploy, and I'll show you how that's a little bit different. Now we're going to run the test, and we're going to pass in all the environment variables that the tests need to run. And many of these are just vars dot. So these are things out of the GitHub variables configuration. So these are just defined in the repo. And some of these are going to be secrets. So the secrets are going to be referred to in this way. So steps. So it's steps of this job. So each step has a name and has an ID, which is optional, but assuming it has an ID. So this is called the ID of this is called secrets. So it's steps.secrets. .outputs is whatever this GitHub action outputs, and this GitHub action is defined that it outputs these secrets named with the thing on the left side of the colon. So I do steps, secrets, outputs, and the name, and that will grab me the secret from this step and inject it into the API tests as an environment variable. So the secrets get injected along with the non-secrets into the environment, and we run the tests. Assuming those tests pass, this is another little bit of an esoteric thing. The auth0 scope parameter has spaces in it. So it's a series of scopes separated by spaces. So like profile, email, offline access, things like that. It's generally very bad form to have environment variables that can have spaces in them. It's nice to have a base 64 option or some escaping mechanism or something besides just spaces in them, because the spaces break a lot of places where you need to push values around, including the thing I'll show you right here. So what happens below here, when we deploy to Cloud Run, we're going to run a gcloud command, and it's going to pass all the secrets and all the environment variables in the command line in a sort of a specific way. And those things cannot have the values, the names and the values of the secrets and environment variables can't have any breaks in them, can't have any spaces in them. because it'll break the command. And if you quote them, which you can do, the quotes will become part of the value. So if you quote the value to get it through the command line parser, you'll have the quotes in the value in the environment variable, which you don't want, and I've confirmed does not work with auth0. So I need to figure out a way to get it in there without quoting it, and the only way to do that is to escape the spaces with the backslash. So that's basically the command line escape, so that when this gets passed in the command line, it will be escaped appropriately for that command line. So a little bit of a hack there to get that to work. And now we're going to deploy to Cloud Run. So there's a deploy Cloud Run action. We're going to pass in some service encounter information. The suffix is the revision is going to be the name of your service, in our case, TeamSpark-AI dash, and if you don't give it anything, it'll give you basically the job number and then some random characters. But we're actually going to call it job-job number. So it'll be exactly job-job number. So if I know I'm looking for job 35, I know exactly what that's going to be named. This also, we had some issues deploying where there were conflicts sometimes with these automatically named revisions, and this got rid of that. So we know exactly what the revision is going to be named. So now we're going to pass in the secrets. We're not passing the secrets that we got up here that are available to us in the steps. We're passing references to secrets in the Google Cloud Secret Manager. So we're saying, hey, this environment variable that is needed by the Google Cloud Run is actually going to come from this secret in Google Cloud Secrets Manager. And I'll show you what that looks like in the deploy so you can just sort of see that. So we're going to pass in some secrets and some environment variables. We're going to say to overwrite in both of them, meaning this is the complete set of secrets and environment variables. And we're not going to use any existing secrets or environment variables. So we have a no traffic flag. So if we said no traffic is no, then this will be false. So that means we will get traffic. And then we will tag this with staging. If there's no traffic, we'll tag it with staging. So pretty straightforward. Then we're going to show the service URL. So if we're taking traffic to this, then this is just going to be the main URL of the Cloud Run. If we're not taking it and we label it with staging, this will be the staging dash URL that you'll be able to use to test. So you can go to this Cloud Run job and grab the URL and then use that URL to test. And you could do that with via automated tests that were later in this job also. And then the last step is that we have to reroute all the traffic to latest if we're trying to route traffic to this. And the reason is that it's not really clear in the documentation, but when you set up Cloud Run, there's a routing rule that is this rule, which is latest equals 100, which is the release that's the latest one, which is automatically tagged that way. We'll get 100% of the traffic. And as soon as you say, I don't want to pass any traffic to the latest, it's essentially going to overwrite this rule. So if you do want traffic to go back to latest, you have to re-put that rule back in place. So you have to rewrite that rule. So if we are routing traffic to the latest, then we're going to just send this rule back and say latest equals 100. So that's basically how that works. And we can go look at a run of it. I've only got one in here because I had to do some repo cleanup. But yeah, you can see all the steps. So there's my route traffic. There's the service URL. So in this case, we are routing it to latest. So that's the internal URL to the latest revision. And then let's go look at what that revision looks like. So let's go to Cloud Run. Okay, so I see that this was job number 3. So let's go look at revisions. So this is API job 3, traffic, 100% traffic to latest. I did this yesterday. So that's the revision that it pushed. And if we go over here to the YAML, we can see a couple things. So there are some labels that are put on here automatically. It's easy in the GitHub Actions to add other labels if you wanted to put other things on here. But one of them is the commit SHA. So I can see the get hash of the code that was used to deploy this release. And I can see that it was managed by GitHub Actions. So basically, I know the get hash. And I know the revision, the job that actually built this release. So I can sort of put those things back together. And then the other part of this to show is that we're going to go down here. You can see all the environment variables that we passed in. None of these are secrets. Now, if we had passed these secrets in the GitHub action as environment variables, they would be right here. You'd be able to read them, which obviously you don't want. You don't want anybody who has access to this sort of job management state to be able to see the secrets necessarily. So that's why we actually pass them as references to the Google Cloud Secret Manager secret. So this is essentially saying, like here, this is saying you're going to get this CDN URL. The value is this. This is saying auth0 client secret. The value is from, it's a secret key reference, which means Google Cloud Secrets Manager of this name, and you want the latest revision of that. So all the actual secrets are just references to Google Cloud Secrets Manager, which is what you want. So you're not exposing any of those to anybody. Yeah, and that's kind of the gist of that. Works pretty well. It takes about 20 minutes. I don't know why it takes that long. It takes longer than it does to run it from the local machine. Yeah, but it works pretty reliably. So I will say, I think CI/CD is an extremely worthwhile investment at any scale. It's an absolute must. Even as a single developer, I think there are some advantages to it. If you use GitHub, I would say learn how to use GitHub Actions. If you don't already know, it's worth spending an hour or two, watch some videos, do a couple of little simple workflows. It's super easy, powerful. There's like tons of things in the marketplace. It's an awesome CI/CD system. Like, I don't know why you would use anything else, unless you've already had something else. I would say adopt a secrets management solution sooner than later. I regret waiting as long as I did. I wish I would have just started it like right from the beginning. So as soon as I started generating keys and certificates and API keys, that I had a place to put them instead of just trying to stash them somewhere where I wouldn't forget. And save you some time later. It'll be more easier to manage and more secure. The general idea is, like, if releasing is painful, you're not going to do it as often as you should, or maybe not at all. Like, because I didn't have this set up, I didn't test on mobile devices until much, much later than I should have. I wouldn't have done this right out of the gate. Like, I don't think it's worth spending your first 2 weeks in a startup figuring out how you're going to do CI/CD, but I wouldn't have waited 7 months either. I think a couple months in was probably the point where, like, all right, I kind of know what this is now. I know I've got these mobile apps. I know I've got this website, this API server. Let's go figure out how to get, this managed, understand what the dependencies are, and build this in a sort of predictable way. And it probably would have saved me a lot of time and pain after that if I'd done that sooner. I'm super happy I have it now. Like, I'm really excited about the fact that I can just do these push button deploys, and it's super reliable. It wasn't terrible before on the website because I would run the tests myself manually, locally, and have pretty good idea that when I check those in and pushing to main would automatically deploy to Vercel, that everything was going to be fine, and it generally was. But it's much nicer now that I've actually got this full system. I can go. I know that it's going to run the test before it deploys. I can go in and look at the output of it. And it's easy enough that I can do it, especially with the mobile apps. Like, I can make one tweak, push a button, and be testing the tweak on a device, which I wouldn't do if it was as hard to build as it was before I had this. So anyway, super worthwhile. Generally, I would say, don't wait too long to figure out your CI/CD. Probably won't take you a week if you know the tools a little bit better. Maybe you don't have quite as complicated of an environment, but yeah, definitely worth jumping into. And Secrets Manager right away. And GitHub Actions is awesome. So yeah, that's about all I have to say about that. We'll be back with more soon. Thanks.